After concluding the drawing of our tan theta, there is something I still found in SSCE syllabus. I call it more advanced graphs in trigonometry. But more of this type of graph we are going to discuss now and draw will be found in your A-level syllabuses. But this part we want to draw now is still within the periphery of your SS syllabus. So I want to use this question to touch all the points, all the sites that the syllabus have for you in this SSCE level. So this question says that we should draw the graph of y is equal to sine 2 theta minus cosine theta for 0 degrees less than or equal to theta and theta less than or equal to 180 degrees. That means we are going to take the values of theta from 0 to 180. That's what it means there. The using scale of 2 cm represents 30 degrees on the theta axis, that is the x axis, and 10 cm representing 1 unit on the sine 2 theta minus cos theta axis, that is the y axis, the vertical axis. From the graph, find A, the solution of sine 2 theta minus cos theta is equal to 0, 0.2 and minus 1.8 to the nearest 1 degree. I'm going to teach you how to find the solution of this kind of equation in such graph after we draw them. Then B said we should find the maximum value of y, and we should correct it to 1 decimal place. I will also teach you how to find the value of y. Some authors or some examiners, instead of saying find the maximum value of y, they will tell you find the maximum value of this equation or this expression sine 2 theta minus cos theta, because the graph you are going to draw has also told you that y is equal to sine 2 theta minus cos theta. So they can tell you to find the maximum or minimum value of sine 2 theta minus cos theta, or find the maximum or minimum value of y, just as they have in this equation. Whichever way they go, they are saying the same thing. Let's go ahead and construct the table of values from which we make extracts what we are going to plot in our graph. The table of value for this kind of expression is more complex than the table of values we plotted when we were plotting the graph of sine theta, cosine theta, and tan theta. It will be complex in the sense that it will have more than 2 columns. To have the column for theta, to have the column for cosine theta, to have the column for 2 theta, and maybe finally not even finally, there will be column for sine 2 theta, then before the final column of sine 2 theta minus cos theta. So we are talking of 5 columns, and in that 5 columns we are going to have the extract of what we use to plot the graph. So just as I said, in the table of values we are going to have theta, we are going to have cosine theta, we are going to have 2 theta, we are going to have sine 2 theta, then finally we are going to have a column for that equation, sine 2 theta minus cosine theta. So these are the 1, 2, 3, 4, 5 columns that we are going to have. So I'm going to divide it. I would like you to pay acute attention because we are going to have more practical thing in this example. We're going to be more busy because this is more advanced. So the values we are going to have for theta are 0, 12, plus 12, 24, plus 12, 36, plus 12, 48, plus 12, 60, plus 12, 72, plus 12, 84, plus 12, 96, 18. We'll be stopping at 18. All right. We are going to divide these things into that. Please pay acute attention as we go ahead. I'm going to use 1, 2, 3, 4. I'll fill them all. Then remove the camera because of wasting our time and complete the rest. That's how we must do it, because if you should be here trying to calculate the whole columns, it will waste much of our time. That means in this concept we are going to have like only this concept, only this question, we're going to have like 2 plates of DVD. Okay, we have 0. What is cosine 0? Cosine 0 is equal to 1. So here we have 1. 2 theta is going to be 2 times 0, which is 0. Then sine 2 theta means the sine of this 0. Let's check. Sine of 0. Sine 0 is equal to 0. Now, sine 2 theta minus cos theta means 0 minus cos theta. Sine 2 theta has this value. Cos theta has this value. So sine 2 theta minus cos theta means 0 minus 1. 0 minus 1, which is minus 1. So we have completed the first column. Second column, we have 12. Then cos theta. That means cosine 12. Let's find cosine 12. We have 0.978, which will give us 0.98 in 2 decimal places. So we have 0.98. Now, 2 theta means 2 times 12, which will give us 24. Sine 2 theta means the sine of 24. Sine 24 is giving us 0.401. which is 0.1 in 2 decimal places. So we have 0.41, 0.406. But in 2 decimal places, we come down to 0.41. Now we have sine 2 theta minus cos theta. That means 0.41 minus 0.98. The value is minus 0.57. We have concluded the second. The third column now, cosine 24. Let's find this value, cosine 24. 0.9 in 2 decimal places. So we have 0.91 in 2 decimal places. 2 theta means 2 times 24, and it will give us 48. Sine 2 theta means the sine of 48. So we have sine 48 is equal to 0.74. 0.74. Now sine 2 theta minus cos theta. is 0.74 minus 0.91, giving us minus 0.17. The fourth column that we are going to show you is 36. Cosine 36, let's find the value. Cosine 36 is giving out 0.81 in 2 decimal places. 0.81. Now 2 theta means theta, that is 36 times 2. 2 times 6 is 12. Right, to raise 1. 2 times 3 is 6 plus 1. You have 7. Now sine 2 theta means the sine of 72. So let's find the value. Sine 72 has this value, 0.95 in 2 decimal places. 0.95. Now sine 2 theta minus cos theta means 0.92 minus 0.81, giving us plus 0.14. So it is in this sequence you are going to fill all the columns. I'm going to pause now. By the time you see the whiteboard again, I must have completed the whole columns. Then we now transfer whatever we have here into our graph paper as usual and begin to plot our graph. Now this is the table of values completed. You can see the columns and the figures that are attached to them. Now, irrespective of what our formula is, y is equal to sine 2 theta minus cos theta, we are going to plot all the values we have under sine 2 theta minus cos theta, which are these values, against its corresponding values of theta. This will be on the vertical axis, the y-axis. Y theta will be on the horizontal axis, which is the x-axis. So the next thing we do now is we go down to our graph paper, copy down this table of value on the exercise book side of our graph paper, and begin to plot these points after calibrating the graph portion of our graph paper. So that is the next thing we are going to do now. Now this is the graph paper. I have copied down the table of value we had on the whiteboard on the exercise book portion of our graph paper, and that is what you can just see. It was based on the scale that we now calibrated the graph paper portion of the graph book in this manner. So this is the theta axis, the x-axis, while this is the sine 2 theta minus cos theta axis, that is the y-axis. Now from the scale, the scale says 2 cm represents 30 degrees on theta axis, that is the x-axis, and that was why you know from here to here is 2 cm. That was why you saw 30 there. The next 2 cm is another 30, which made it 60. The next 2 cm is another 30, which made it 90. The next 2 cm is another 30, that made it 120, until it ended in 180 degrees. Then along y-axis, 10 cm represents 1 unit. So that was why you saw it is synonymous to the sine theta and cos theta and tan theta graph we plotted before now. From here to here is 2 cm, 4 cm, 6 cm, 8 cm, 10 cm. And you can see from this place to this place is just 1 unit. We only subdivided it into smaller figures that are below 1, and that is in respect to the scale that says that 10 cm represents 1 unit along the y-axis. Now, after the calibration of the graph, the next thing to do is to plot the values that we have on our table of values. Remember, you are plotting sine 2 theta minus cos theta against theta. You are plotting these values that have sine 2 theta minus cos theta against theta. So the first value you have there is minus 1. So minus 1 will be plotted against theta, which is 0. So if you come to the graph paper, you discover that 0 as theta is this place, then minus 1 is here. So this is the place you're going to plot 0 and minus 1. That is the first point we are plotting. Let's go back to our table of values. The second value says minus 0.57 as against 12. In this case, the distance from here to here is 30, and you have 10 small squares in between the space. So if you want to have the value of one of the small squares, the simple thing you do is you divide 30 by 10. It will give you the value of one of the small squares. 30 divided by 10 will give you 3. That means each and every of this small square is 3 degrees. 3 degrees. Now that you are looking for 12 degrees, know that the second on the column is 12 against minus 0.57. So 12 degrees is going to be 0, 3, 6, 9, 12. So the figures you are going to have there, which is 12 apart from your 4-figure table, from your table of values, will now be difference of 4 small squares. Unlike when we were plotting the graphs of sine, cosine, and tangents, that 2 small squares were equivalent to 12. But in this case, it is 4 small squares, because one of the small squares is 3. 3 times 4 is what I will give you 12. So the 12 degrees is now 1, 2, 3, 4 small squares, and we are to plot it against minus 0.57. So just go to the 4th small square, 1, 2, 3, 4, and trace it down. We want to plot it against minus 0.57. Minus 0.57. So this is minus 0.2. 0.22, 24, 26, 28. Okay, minus 0.5. So it's more than minus 0.4. So let's start from here. Minus 0.4, 42, 44, 46, 48. And we're looking for minus 0.47. So minus 0.47 will be between minus 42, 44, 46, 48, 0.5, 52, 54, 56, 58. Minus 0.57 will be between minus 0.56 and minus 0.58. So the next place we're going to plot is exactly at this point. So that is the second place you have plotted. Remember, the first place was at 0. Second place is here. So let's go to the third. The third is 24, and 24 should be plotted against 0.17. 24 is going to be the next 4 small squares. We plotted here. We have 1, 2, 3, 4. It's going to be here. And we are plotting it against 0.17 as we saw on the table of values. So minus 0.14. So trace this line up. This is 0, 0.02, 0.04, 0.06, 0.08, 0.1, 0.12, 14, 16, 18, and we're looking for 0.17. So it's going to be between here and here. So the next place we're going to point is in between this small square. So we're going to plot here. Now the next value after that is 36, and 36 should be plotted against 0.14. Now plus 0.14. Remember, all the values we plotted earlier, the 3 values we plotted earlier were on the minus axis. Now we are entering the positive axis. So we have 0.14. 0.14 against 36. Now this is our 30. This is 33. This is 36. Or we should just count 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 4 small squares. That is our 36. We have to plot 36 against plus 0.14. So this is 0, 0.02, 0.04, 0.06, 0.08, 0.10. We're looking for 0.14. So this is 0.1214. So this is exactly the place we are going to plot this particular one. So we plot it here. The next is after 36 is 48. And we are plotting 48 against 0.32. So this was the last place we plotted. Just count 4 small squares. 1, 2, 3, 4. And we are plotting it against 0.32. So 1, 2, 3, 4. Take it up. 0.32. So this is 0.2, 0.22, 24, 26, 28, 0.30. We're looking for 0.32. So this is 0.32. But this is exactly where we're going to plot this particular one. The next is 60. 60 is to be plotted against 0.37. So we have our 60. Our 60 is clearly written, or if you can count from here 1, 2, 3, 4. You can see it tallies with where we have 60. And we have to plot 60 against 0.37. So this is our 0.2, 22, 24, 26, 28, 30. We are looking for 37, 32, 34, 36, 38. So between 38 and 36 is 37. So we're going to plot 37 here. against 60 degrees. So these are the points that I want to use to illustrate to you how to plot the points. If we should be plotting the numbers one after the other, the whole of our time will go. When next you see this graph paper, I must have plotted the remaining values from 72 till 180. Now you can see we have finished plotting the points. Now the next thing we should do now is to join the plotted points with our broomstick. This is the broomstick we're going to use in joining it, as I have instructed you. Use a broomstick and join 3 points at a time. Try to join 3 points at a time. But when you get to like 1, 2, 3 points that are close to themselves, you can use your hand carefully and join that 3. But from here down, use ruler and join 3 points. When you get here, you can use your hand and connect. Then use the broomstick and cover it up. It will help to give you a perfect or a more perfect curve. So when next you will see this graph paper now, I must have joined these plotted points to give us the required curve. Now I have finished joining the plotted points. You can see the curve that is the resultant. So that is the curve of sine 2 theta minus cos theta plotted against theta. Now let's go ahead and answer the questions that follow suit. The question is that from the graph A, find the solution of sine 2 theta minus cos theta is equal to 0. Sine 2 theta minus cos theta is equal to 0. Remember that sine 2 theta minus cos theta is y. You can see it here. This is the graph of y is equal to sine 2 theta minus cos theta. So what they are asking you there now is, what is the value of theta when y is 0, or when sine 2 theta minus cos theta is 0. So if you come to the graph, you find out that this is the point where y, or sine 2 theta minus cos theta, which owns this whole axis. It is at this point of intersection that it is 0. So trace the line of intersection along x-axis. Trace it along x-axis. All the places the x-axis cuts the curves, pick the value of degrees you have there. That is the answer to that question. You can see at this place, he cut it here at 30 degrees, he cut it here at 90 degrees, and he cut it here at 150 degrees. That means question number A. The solution to that equation are 30 degrees, 90 degrees, and 150 degrees. Now the second question is, find the solution. You can see it's red. Find the solution of sine 2 theta minus cos theta is equal to 0.2. Just the same thing. Where y is 0.2, what is the value of theta? 0.2. Look at the place where y is 0.2, or cos sine 2 theta minus cos theta is 0.2 at this place. So trace the number. All the places it cuts the curve, read their values down. In the first place, it cuts it at this place, so read the value of theta down. So any value you have here, is the value you are going to read. So you are going to shade this place very well and read the value there. That is the first value. It crosses and cuts it again here. So you are going to trace this one also down to x-axis and shade it again. That is the second value for which that statement sine 2 theta minus cos theta is 0.2. It crosses it again and gets to this side. So at this point also it cuts the curve. So I'm going to trace the line down again to x-axis and give it another point. So the three places now, whatever value of theta is there is the values for the second question. So let's read this. So this is 30, this is 33, 36, 39 degrees. So the first value is 39 degrees. Write it down. 39 degrees. Let's read the second. Second is here. Here is 60, 63, 66, 69, 72, 75, 78. So this place is 78 degrees. So write it down. 78 degrees. The last is here. This is 150, so we have 153, 156 degrees. So write it down. And 156 degrees. That answers the second. Then the last for question number A says find the solution of sine 2 theta minus cos theta is equal to minus 1.8. So go to your graph paper. Where is minus 1.8? Look at minus 1.8. So read the value where each line cuts the curve. The line cuts the curve only at a place, and that is here, the second small square. So trace it up to your x-axis. Trace it up to second small square. Trace it up to your x-axis. So this is the place. Remember, each of the small square is 3 degrees. So if this is 3 degrees, this is 6 degrees. That means the answer to the third portion of question number A is 6 degrees. So write 6 degrees. This is question number A. Let's call it AI. Then AII. So we are finished with question number A. So these are the answers to question number A. I, and III. So let's go to question number B. Question number B says we should find the maximum value of y correct to 1 decimal place. Maximum value of y. Remember that y is equal to this statement, of which we plotted the graph. Y is equal to sine 2 theta minus cos theta. And we plotted sine 2 theta minus cos theta on the y-axis. That means the y-axis is a representative of sine 2 theta minus cos theta. So if they're asking for the maximum value of y, so they're asking for the maximum value of the curve along y-axis. And if you look at the curve started from here, which is the minimum value. Assuming they asked for the minimum value, it could have been minus 1.0. Started from here, went up, came to this place, it curved, came here, curved up, and ended at this place. So this place now is the highest value. So trace it to the y-axis that represented sine 2 theta minus cos theta. What value do you have here? This is 1.0. That means the maximum value of y is 1.0. So we can write that one here. Maximum value of y. Of y is equal to 1.0. And that has brought us to the end of this question. I am going to highlight some other graphs that examiners might require of you to plot, but those ones I'm not going to plot them. But I will explain to you how you go about them. Maybe at your time you can plot those ones by yourself. Because of time, I want to use just this question to teach you about what we have on the whiteboard. More advanced graphs on trigonometry. We just finished plotting the graph of sine 2 theta minus cos theta. Questions on more advanced graphs on trigonometry can also come. Let me tell you to plot the graph of minus tan theta. So we tell you minus 2 tan theta. So we say cosine theta, it must not always be tan. Maybe cosine theta plus 3. Sine theta minus 1. It can come a series of this. However it comes, what you do is whatever the term is what the value you will plot on the y-axis against the corresponding values of theta on the theta axis, which is the x-axis. For instance, this now, you are going to calculate tan theta. If tan theta gave you 0.25, that means minus tan theta will be minus 0.25. So it will be these values you will get and plot on the y-axis. If it is this one, minus 2, whatever you get tan theta to be, multiply minus 2 to it. It will give you the values you have in your table of value. Likewise, this cos theta. If you find the cosine of the theta, add 3 to all of them. It will give you the value you plot on the y-axis. If you find sine theta, whatever you find sine theta is minus 1 from it. It will give you the series of values you will have plotted on the y-axis against whatever theta is on x-axis. So with this, we are concluding our discussion on